Welcome everyone. My name is Sathar. Today we are going to understand about second normal form with some example and solve numericals. To go further and understand about 2NF, let's see what is normalization. Normalization is a database design technique that organizes table to minimize redundancy and dependency, ensuring data integrity and efficiency in data management. Redundant data means the same data you are storing the same data again and again in the tables, which is actually the wastage of the memory, and the normalization is done to reduce that only. The key benefits of normalization include reduced data redundancy, improved data integrity, and optimized database performance, making it easier to update and maintain. The different types of normal forms are first normal form, second normal form, third normal form, BSNF, 4NF, 5NF. Today we'll only learn about the 2NF only. To go further, what let's see in short what is 1F. 1NF means for the table to 1NF, it should follow the four rules. It should have only single value attributes. Values stored in columns should be of same domain. All the columns in the table should have unique names, and order in which data is stored should not matter. 2NF. For a table to have 2NF, it should be in first normal form and it should not have partial dependency. What is partial function dependency? When a table has primary key that is made up of two or more columns, and then the column not included in the primary key in the table should depend on the entire primary key, not the part of it. If any column which is not the primary key depends on the part of the primary key, then we can say we have partial dependency in the table. If a relation has only two attributes, it will have never have partiality. If the candidate key contains only single attribute, then it is free from partiality. Uh, like there is in the example with relation which contains A, B, C, D, E, F, each has six variables. The candidate keys are A, B, C, and A, C, D. We will learn further how to find it. Uh, if the relation is like X to Y and the X is the subset of a primary key. It is called a prime attribute, and it is having a non-prime attribute which is not a subject or not a super key or primary key. Then there is a function dependency. Now let's understand with a numerical. Like there is in the table, in the fourth column EMP skills, there are multiple values in a single cell, like Python JavaScript, which violate the 1NF property. So it is not in 1F, so therefore it is also in the 2NF. Like there, what is the partial dependency? Let's understand it in detail. Like there are two tables, students and subjects. Student contains the student ID, student name, branch, and subject contains student ID and subject name. Okay, and there is also a third table of score which contains student ID, subject ID, marks, and teacher name. But you can say that in the score table, student ID plus subject ID is the candidate key. But teacher name only depend on the subject ID. At the one teacher teaches only one subject, so it is related to only subject ID only. So, but so there is a partial dependency here. So we have to normalize it and convert it into second normal form. And to do this, we will update the subject table, and subject table will be look like this: subject ID, subject name, and teacher name. And score table will look that as student ID, subject ID, and marks. Now let's understand with an example. Now understand 2NF better, let's take an example. Like this similar type of this question can be also be asked in your university exams. Here the relation is given T which contains four variables and has some function dependency P to S, PQ to R, PR to Q, and S to P and S to Q. We have to check whether it is in 2NF or not. For that we will first find the candidate key. To find the candidate key, we will first write all the variables in this order and we'll make the arrow from the one variable to another variable. Like that, P derives S. So we will make the arrow from P to S, and then we will see that from which variable how many arrows are going and which is deriving all the variables. So that is the candidate key. So we can conclude that P and S are the candidate key. Like we have seen in the PPT, that if there is only one variable in the candidate key, then the partial dependency cannot happen there. So it is in the 2NF. Let's take the another example. In this example, there is a relation R which contains 5 variables and there are 3 dependencies A to B, B to E, C to E. We have to convert it into 2NF. So let's first find a candidate key. We can easily see that A and C has a candidate key, and candidate key is of 2 elements. And from the first function dependency we can see that A to B, it is a partial function dependency because A is the part of the candidate key and it is the prime attribute, and which is deriving a non-prime attribute. So it is there is a partial dependency. Similarly, C to E is also a partial dependency which violates the 2NF property. Now to convert it into 2NF, we will break this relation into some n number of relations. The short way to do this is that there like the first and third relation are violating it. So we will first make the two relation containing those two only, and we will make the another relation containing the candidate key, like the R1 ABE, which contains A to B and B to E. Like either in this particular R1 relation, A is the candidate key and there is no 2NF property violation. This R1 is in the 2NF. Similarly, R2, in which C derives CD, C is the candidate key and R2 is in 2NF. But in our original relation R, candidate key was AC, and in no such relation in R1, R2, A and C are coming simultaneously. So we will make the another relation R3 which contain AC. So in this way we will can convert a relation into a 2NF.